This is the Level 2 2015 Waves exam. For this exam you will need a ruler. Right. See that? Question 1. Seela is experimenting with curved mirrors. She places a lighted candle in front of a concave mirror and obtains an image on a screen. State the nature, real or virtual, and the orientation, upright or inverted, of the image. Well, out of the mirrors, the only mirror that can produce an image that can be projected onto a screen is a concave mirror. And in order to produce a real image onto a screen, in order to produce an image onto the screen, it has to be real. Yeah. And if it's real, it means it's inverted. And you just have to play around and know this. You just have to play around with real mirrors and just know that's the case. Question B. The image in front of the candle is formed 25 centimeters in from the mirror. That's a positive number because it's in front of the mirror. And the focal length of the mirror is 16 centimeters. The height of the image is half a centimeter. Calculate the distance of the object from the mirror and the height of the object. So let's write down what we've got first. We've got focal length equals to 0.16 meters. I just change everything to meters because it's the SI unit. Height of the object, height of the image HI to 0.005 meters. DI, distance to image, is equal to 0.25 meters. Right, and we're trying to find out the distance of the object from the mirror. So we're trying to find out DO equals, I have no idea, and we're trying to find out the height of the object. So height of the object HO equals question mark. So that's what we're trying to find out. So the formulas that we are given is 1 over the focal point equals 1 over DI plus 1 over DO in any order, DI plus DO or conversely. So let's just rearrange that. We have F, yes, we have the focal point. We have DI, so we can find DO. So we'll start with finding DO. DO is equal to distance to the object is equal to 1 over F minus 1 over distance to the image. Take the inverse of that, and that equals 0.44. But let's just double check. So we've got 3 significant figures, 3 significant figures, 3 significant figures, which means our answer needs to be in three significant figures. So 444 meters. Right. Got DO, now we need to find HO. So we'll find DI over DO is equal to, we see that, HI equals over HO, which is also equal to the magnification. We have DI, we have DO, we have HI, so we can find HO, which means we need to do a little bit of rearranging. HO is on the bottom. So we're going to move that HO to this side, DO over to this side, DO over to this side. I'll let you do the algebra, but DO over DI times HI equals HO, and if we plug those numbers in from up above, we should get 0.89 centimeters or 0.0089 meters. Yeah, and I've made a mistake. This should be in 3 SF, but I can't be bothered changing that. Right. Seela then places the candle in front of the convex mirror. Explain why she was unable to get an image of the candle on the screen. It's a convex mirror, sorry. Convex mirror. Convex mirrors produce virtual images. That's all we really need to say. So convex mirrors So convex mirrors produce virtual images. Thus, this is because the rays diverge and will not meet in front of the mirror, front of the mirror to produce an image. And that's pretty much why. So if you use a convex mirror, you can never use a convex mirror to project an image onto the screen. So I've said that produce virtual images. This is because the rays diverge. Keyword here, diverge. And that's really about it. Right, next question. We see that. Dentists use curved mirrors. Write a comprehensive explanation for why dentists use curved mirrors instead of plain mirrors to examine a tooth. In your answer, you should include the name of the type of mirror they use and a ray diagram. So what we'll start off with, well, let's just have a think. If we used a convex mirror, so if we just used a convex mirror like so, no matter what, we always get an image smaller than the object. And the image is always formed behind the mirror. And that's where the rays, if the rays diverge out this way and then out like that way, so we backtrack the outgoing rays, it always forms an image behind the mirror. So we need to use a concave lens. So what we're going to do is going to draw a ray diagram. Let's just put in our principal axis here, and let's put in, call that concave. No need to draw a neat wee sketch. So if we have and this is going to be our focal point. I'm not going to worry about the focal point on the other side. If we have an object in front of the focal point for a concave mirror, it gives us an enlarged upright image. It is virtual, but it doesn't matter because we can still see it. We just can't project onto a screen. So that's what you'd use. They're commonly used as makeup mirrors as well. Anyway, so you just need to sort of know this off by heart. Draw an image in front of our focal point, and let's just do a ray diagram for that. So we're going to have one in parallel, one ray going in parallel, and then it's going to go back out through the focal point using a ruler. Make sure we draw arrows to show where the rays are going. Yep. And then we're going to have one in through the focal point. Oh, this is going to be tricky, isn't it? And it meets somewhere up here. Then it's going to go back out parallel. Don't worry that you're drawing all over this. And that's just about enough. And now we can backtrace these rays. Backtrace the outgoing rays only to find where the image would form. Goodness, this is large. I think I might have made a mistake and done this a little bit too big. But that's alright. So here we have our upright enlarged image. Try and sketch that over there. Right, so here is our ray diagram. So we might just put upright and enlarged. There we go. Dentists use concave mirrors when the object is placed, it should be placed in front. Can we see this? I'll move this up a bit. Placed in front of the focal point and upright, enlarged image is formed. Flat mirrors. So we need a flat mirrors don't produce enlarged images. Obviously, you know that from experience. Enlarged images. And convex mirrors produce diminished images. Which is not useful when looking at teeth. Right, so have we answered the question? We have name of the type of the mirror, name of the type of mirror they used, concave again, ray diagram. Yep, so we got a ray diagram of the object in front of the focal point, so we get an enlarged upright image. There we go.